You know, when we talk about consciousness, it's so easy to get stuck inside our own heads, right? I mean, our human experience is the only one we really truly know. But what if we tried to imagine a mind built on a completely different blueprint?
Okay, get this. This quote, it sounds like it's describing some kind of creature from a sci-fi horror movie, doesn't it? But that's a philosopher, Peter Godfrey Smith, describing something very, very real. He's talking about the brain of an octopus. No, I'm not kidding. Its esophagus, the tube it eats with, goes right through the middle of its brain.
So that just has to make you wonder, right? And this is really the central question for us today. How on earth does an animal that literally eats through its own brain experience the world?
To even start to wrap our heads around that, we've got to take a trip. We're going way, way back into our shared evolutionary past to look at a creature that feels like an alien, but it's living right here in our own oceans.
It all starts with the basic hardware, the nervous system. At its core, it's just a collection of specialized cells with these long branching arms that basically zap each other with signals. You can think of it like the fundamental wiring that allows an animal to do, well, anything.
But here's a really crucial distinction. Just having wiring isn't the same thing as having a command center. A brain, that's different. A brain is when you take all that wiring and concentrate it into one powerful, centralized hub designed for complex control.
So that begs the question, right? Why even bother building these super complex command centers in the first place? Well, the answer, it turns out, is pretty dramatic. It's a story of eat or be eaten, a full-blown evolutionary arms race.
This timeline really lays it all out. For millions and millions of years, life in the oceans was pretty chill. It's a period called the Garden of Eden. Sure, animals had basic nervous systems, but they kind of just floated past each other. Then, boom! Around 540 million years ago, the Cambrian explosion kicks off. And with it come the first true predators. All of a sudden, the game completely changes. There's this intense pressure to get smarter to hunt your prey, and an even bigger pressure to get smarter so you don't become prey.
And what followed was this incredible battle for the seas. At first, the ancestors of today's octopus, these early cephalopods, they were the kings. They were like these big, slow-moving zeppelins dominating the ocean. But then evolution threw a curveball, jawed fish. They were faster, way more agile. Think airplanes versus zeppelins. They just took over. And that constant back and forth pressure is what drove the evolution of bigger, better brains on all sides.
But here's the cool thing about evolution. It doesn't just have one single answer. This crazy arms race led to all sorts of wildly different solutions for how to build a mind, which brings us right back to our friend the octopus and its truly bizarre mind in the arms.
So you end up with these two totally different blueprints for a brain. You've got our model, the human model. It's super centralized. Everything is controlled from the top down by our two big cerebral hemispheres. Then you've got the octopus. It's a completely different approach. There's a smaller central brain, sure, but it's supported by these huge clusters of neurons in each arm. It's not top-down, it's spread out, totally distributed.
And when I say distributed, I mean it. Just look at these numbers. It's wild. More than half, almost 60% of an octopus's neurons aren't in its head at all. They're out in its arms. Can you even imagine that? If most of your brain power was in your arms and legs?
This is so weird that early scientists described the nervous system in the arms as being, and this is a great quote, curiously divorced from the central brain. They looked at the wiring and thought, there's no way the main brain is controlling all of this directly. The connection's just not big enough.
Probably the best analogy for how this works comes from the researchers themselves. It's like a conductor and a jazz band. The central brain is the conductor, setting the general theme, but the arms? They're the jazz musicians. They can follow the conductor's lead precisely when they have to, say to escape a predator, but a lot of the time, they're just riffing, improvising, exploring their little patch of the world all on their own.
Okay, so if the hardware is that alien, what does that mean for the software, for the actual experience of being an octopus? What about something really fundamental like pain? Can an animal built like this feel pain in a way we'd even recognize?
Well, this is where things get really fascinating. A biologist named Robin Croak designed a landmark experiment to try and find out just that. So here's what she did. An octopus got a minor, harmless injection of acetic acid in one arm, and its reaction was incredible. It wasn't just a simple reflex, like pulling away. No, it began to protect, to groom, and to specifically tend to the injection site. It then learned to actively avoid the place in the tank where the painful event happened. But here's the real clincher. When a local anesthetic was applied to that spot, all of those complex, protective behaviors just stopped.
That's not a reflex. That is a complex, surprisingly human-like network of effects. And let's just pause on this. We're talking about an animal whose last common ancestor with you and me was a tiny little flatworm that lived 600 million years ago.
And a discovery like that, well, it pushes us way beyond just scientific curiosity. Suddenly, we're wading into some really deep and frankly startling ethical questions.
Because here's the thing. It isn't just about octopuses. Scientists are finding similar networks of effects, this evidence for complex, pain-like states in other invertebrates. We're talking about crabs, lobsters, and even shrimp.
And this is not some abstract philosophical problem. Look at this number, 440 billion. That's the estimated number of farmed shrimp killed for food every single year. Let that sink in for a second. To put that into perspective, scientists estimate that only about 100 billion humans have ever lived.
Which leaves us with a final profound question to consider. The octopus, the shrimp, the crab, their minds evolved on a path that diverged from ours hundreds of millions of years ago. Their experience of the world is almost certainly alien to us. But if a mind is profoundly different from our own, does its experience matter any less?